Welcome back. Our next speaker is a physicist, artist, maker, musician, and fashion designer. She currently works as a creative technologist and manager at the Silicon Valley Garage at Microsoft. This is a place where the company's experimental projects come together. Kitty's recent work in fashion technology focuses on cutting-edge technologies to bring together garment design and manufacturing processes. Please welcome to the stage, Kitty Yeung.
Hello, everybody. So exciting. It's such a nice crowd here. I'm so honored to be here on stage and talking to you about some of the work I've been doing. So as Mike introduced, thank you very much, Mike. I work at the Microsoft, and the garage at Microsoft has a makerspace, and we run hackathons. We support grassroots ideas. We are like an incubator. So if you're ever in Silicon Valley, you come find me. So I'm going to show you a new design that I did in the garage. This is a garment that is using a new type of fabric. So this fabric is made using basaltic rocks. Is commonly found in volcanic areas on Earth, but you can also find it everywhere on Mars. So I got given this material by my friend in SETI Institute, and he has a company called Made of Mars. They use this material to produce all kinds of daily products. The idea is that one day humans may go to Mars, and because of the raw material is mostly this kind of material, we have to learn how to build things out of it on Earth first. And then if we ever go to Mars, we know how to construct things using that. However, I started thinking, why do we ever go to Mars? Is it because the Earth would no longer be habitable? Is it that our environment is so bad that we have to escape? Therefore, I put this dust sensor on the dress, as well as Adafruit Circuit Express, a circuit playground express. It has all kinds of sensors, as you guys all know, and I'm using the temper sensor on it, as well as the music buzzer. So this is using the dust sensor to detect the air quality, to warn us about air pollution, and the temperature is measured using the temperature sensor on it, and the sound would warn us about the global warming. So this is more like a conceptual piece, and this is how I constructed it. So you start with making a pattern, and you construct the dress first, but then you have to figure out how to sew this type of material onto a normal type of clothing. It's kind of hard, so you have to find the best use case for that. But it also has very interesting stretchy property. So as you can see, this process is very manual, and you have to construct things by hand and put the circuit in. I at first used the Uno as my prototyping starting point and get the code right, but then because I need the sensors and also I always enjoy smaller circuits, I changed that into the circuit playground. And then you have to sew the dresses and solder the circuits and put the wires, hide them, and make it pretty to make it really wearable. And in addition to the dress, I also made some bags. In a similar fashion, you have to carve out the patterns and then sew the different materials together. And it also comes with a different type. This one is like pretty hard. So it's not the best for clothing, but then for something like a bag, it can be quite nice. So this is another another style using different materials. So you can make very interesting things using new types of materials and technologies. And as you saw, the process is very manual. It is important that we share the process so more people can learn how to use it. So I put my projects on Hackster.io and Hackaday Instructables. So open source is extremely important to me, and I really love the maker community because we care about knowledge sharing and collaboration. So I'm hoping to use the open source community to distribute knowledge. Whenever we build something, we share it so that more people can learn how to build. Unfortunately, not everybody is a maker. So I got questions from people who say, where can I buy your things, and how do I purchase them? So just out of curiosity, I started thinking, how do we actually produce a design that we will make first by hand? So I actually managed to produce 3 designs last year that are already in the market. And they all have my paintings on the fabrics. However, you can see that they don't have electronics. That's what I would want. I want this kind of designs to be manufactured. And I had to reduce some of my concept down to non-electronic forms. So that is a graphic using my painting of an eclipse. So that lenticular piece there can change from a full moon to an eclipse. Ideally, I would want to use a flexible OLED to have a more smooth movie running on it. But then we don't really have the technology to do it yet. And I had to reduce it down to something that does not need battery. So I eventually used the lenticular piece. But then this shows you that even though we have some ideas using our current type of technologies, when you want to do production, you hit some sort of barrier. 2 years ago, I was asked to design a t-shirt for Intel at the Maker Faire. So this was my design. The concept is basically a wearable robot that can be attached and detached. It's a little bit like our badges. It uses the Tiny so it has the Intel Curate chip on it. So yeah, back then I was working at Intel. And the idea is it has the distance sensor and a screen and some LEDs on it. So every volunteer who works at the booth should wear a t-shirt like this. And if someone approaches you, it measures the distance. And based on the distance, it will show some hello message to the visitor. And also because the chip also has the gyroscope and accelerometer, it can detect the angle and the motion. So if you can rotate the robot and connect certain circuits on the shirt, it can light up some LEDs showing you the products and what you can make using the products. And the screen could show the product information. So I thought that was a really cool idea, especially at Maker Faire for Intel to demonstrate their platforms. However, we ran into a problem when we wanted to produce them. Turned out that the electronics are much easier to make. So it's all hard material, hardware, and everyone in this room can make this robot. But the soft part turned out to be the harder part to produce. Back then, we could not really find anyone who can do conductive thread sewing at the large scale. This first prototype was made by me by hand. And how do I convince the manufacturers, current garment manufacturers, to start sewing conductive threads by hand? You can do that, actually, when people do embroidery. You can already do that. It's all by hand, but it's extremely expensive. And there's another way, like conductive printing. You can put conductive ink on it and construct a circuit. But also, the technology was not mature. So maybe after 20 washes, the circuit will be gone, or there wasn't really mature manufacturer was able to do mass production of those printed circuits. Turned out we reached out to quite a few places. It would cost about more than 100 to make a t-shirt. So it wasn't at all acceptable as a t-shirt that we would give out to volunteers. So we couldn't do this, so that's why you didn't see this in Maker Faire. That was 2 years ago. But the industry has not moved very far. Eventually, you figure out for a decade, even more, this industry has stuck in this negative cycle. As a creative designer, you have really cool ideas. You can make things by hand. You can use crazy materials and electronics embedded. You can do everything yourself. But then you can't convince the manufacturer to produce them because they haven't seen the market yet. Their decision is driven by the market. However, the market would not show. The mass population, they would not tell you their demand until they see an actual product in the market. Then they say, oh, this is inspiring, I can actually buy this. Then they will generate the market. So we've been in this very negative cycle for a long time, very, very passive. And you will see that because of this passiveness, we have problems in the current garment manufacturing. First of all, it doesn't have enough automation. It doesn't have digital-driven manufacturing. That's why you can't very easily go from a design to a product. And then you also see that you can't really put much technology in garment. You don't see anyone really wearing any real tech fashion. And then the bigger problem is the waste. So we are doing production based on profit and volume. It's not creativity driven or need driven. So we never do enough made to order. Think about manufacturing, we should only do that when someone needs it. But that's not how it is working in the garment, in the fashion industry. So I think this can be solved by technology, all these problems. In addition to making designs, trying to produce some products that would have real technology in them, there's a lot of gaps we can fill in this cycle. So I want to show you a couple of examples how technology can help produce garments. So this is actually how I was able to create 3 designs that are in the market. This is using my painting. This is a website called Sprout Patterns. They allow you to upload any image online and drag the image to the right location. Before you buy it, it renders from 2D to 3D and shows you how they will look like. And then you can place an order based on your size, and you can choose the material, and you can choose, it's basically your graphics. And it's really nice because it can give you a ready-to-wear when they ship it to you, but it can also ship you a piece of fabric with the pattern drawn on it, so you can cut and sew yourself at home. It's really helping makers and creative people to achieve their ideas using technology because of this platform. The other example is 3D printing. 3D printing is extremely advanced now that we can afford buying a machine at home and we can produce things. But also we have services like Shapeways, so you can upload your files and they get produced. Nice thing about it is you can make how many pieces you want. You can produce one or you can produce thousands. You just pay the material fee. And they don't resist making a small volume. In the manufacturing in garment, you have to go to somewhere like China or a factory in the third world country, and you have to have certain volume. If you don't reach that volume, people do not want to produce for you. So there's a lot of resistance in this manufacturing process. And something like this is just a little bit of work, more work than a normal skirt. To an engineer, that's extremely easy. You just add on those pieces and you can draw them. But then the pattern makers will say, oh, this is unconventional and it needs development and it's too much work. And no, they don't want to do it. So I started thinking, why can't garment manufacturing be like electronic manufacturing? Because electronics has advanced to this high level. We can make nanometer size, micrometer size structures. We can make the chips and wafers with extremely accurate structures on them. But garments, fabrics, we can't do that. In fact, there's a lot of similarity between the two types of manufacturing. You can see that in the design stage, you basically need to make a 2D drawing to represent how you would cut and layer different materials. In electronic manufacturing, you draw a PCB and you draw a layout. You send it to a factory in the clean room, and there are engineers helping you, but most of the process is automatic. And you have all the machines that's driven by the design files. And you can produce wafers and chips. You cut the chips and put the chips into the PCB. PCB is also file design driven. And then you package it. Again, is you just make a 3D file and it gets produced. For garments, you start with the 2D design, is telling you how you cut the pieces. And then you go to find a maker, a pattern maker, and they would do the development. First time usually is wrong. The fit is wrong because they just use a visual and some of the 2D patterns usually is wrong, and they send it to you. You tell them how to change it. But then the second time, the fabrics will be wrong. The fit is right, but because the first time they don't use the right fabrics, they use a cheaper fabric, muslin, then you have to tell them you need to change the fabrics. Now the fabrics and the fits are right. The details and notions are missing. Like here's a button, here's some decorations you want, but it's wrong. So you go several times with a lot of errors. Eventually, you can go to the production stage, and people work in very terrible conditions. That's probably a topic for another talk. And eventually, after all this work, you produce something like that that does not have creativity. It's all very basic and cheap materials, and people do not want them. You sell them in the shops. First time you do a discount, no one wants them. You do another discount, eventually it gets so cheap, still no one wants them, you burn them. That's how the industry is running right now. They burn the wasted garments. So after all this work, with all those people in terrible conditions, they produce some trash, and it's polluting the planet. I think if we can run the fashion industry in the same way as the electronic manufacturing, we can solve all kinds of problems, especially the waste. So there are a lot of gaps you can come in. You can produce a platform that allows people to design more creative patterns. So as I showed earlier, the sprout patterns allows you to upload the images in digital printing. But that is only the graphics. That's not, for a fashion designer, you also need the cuts, the shape you want, the structure. You really have to do that in the pattern stage. But we don't really have anything like that that allows us to anyone to design a pattern and then get those cut and sewn and produced. there are other high tech that are kind of tackling different areas of the industry. Yeah, you want fit. You want the right fit before you can buy it. So there are some technology being developed to measure you, to get an avatar of you. Hopefully, it can then have some clothes tried on your avatar before you buy them. But it's not quite there yet, and that is not connected to the design stage. And if you ask an engineer in a big tech company like mine, to use machine learning or computer vision in fashion, they usually would say, I can take a picture of an existing product, and then I can make a recommendation for you. But that's not really dealing with any pain points, because you're not really solving the made-to-order problem. You're not connecting that to manufacturing. So eventually, we need some democratization of the technology. We need a platform for people to connect all of these technologies together to get their ideas produced. I see a lot of collaborations in research and open source, designers, and education. In this room, we have people working in all of these areas. Research will come up with new materials, better and flexible electronics, but we need the open source community to put the technology out there, to make them available for anyone to use them, to design them. And functionality and aesthetics are equally important. So as an engineer, I often see a lot of cool technology prototype, but then they're not attractive and no one wants them, so they don't get the market. So the design is also important. And eventually you need to do education, because any new things you introduce to the world, you have to convince more people. But eventually we are working together, collaborating in this area, but then we don't have enough production. So this is what I'm working on, to drive creativity and need-driven manufacturing. It's not difficult. It's not easy. It's got a lot of pieces in it, but it's not hard, because all you need to do is to turn some engineers into fashion designers. So if you guys have any good ideas that could solve the accessibility and democratization of fashion manufacturing, let me know. That concludes my talk. Thank you.